Hello, everyone. How is the Kotlin Conf? Need to be after lunch, this talk, I would say. Thank you for joining the session. My name is Artem. Right now, I'm team lead of Kotlin.js team. Previously, I used to work in Kotlin WASP. And also, I participate from JetBrains in TC39, the committee who is standardizing JavaScript. And I help with the source map specification there. And today, main goal for this talk is actually to give you a preview what is already existing in Kotlin, and also what is to be landed quite soon, or just work in progress what we have. And of course, share our roadmap, what are the next items what we're intending to have. However, to make it more fun, for you, more useful, and to have more takeaways, I would say that there will be some extra outcomes from the talk. So the first one is definitely nostalgia about early days of Kotlin, early days of KMP. Maybe some of you also did a front end in the early 2010s. So maybe it will be nostalgia about these quite old days about front end. For sure, I hope after this talk, there will be much clearer when JS target fit for you or doesn't. Also, we will dive into the ecosystem, what we have right now, to solve like your issues or your use cases for web. And for sure, I will share some different starting points for different use cases. So the plan is quite simple. It's standing in the title. We will go through the past, present, and the future. Let's start with the past. And it was quite far from today. Let's just run to somewhere around 2012. Quite a nice year was there. iPhone 5 was released, and a lot of memes about its tallness. So Taylor Swift is top on the chart. People like sharing how great was Season 2 of Game of Thrones and how bad was ending of Mass Effect 3. And the first commit appeared regarding Kotlin.js. And you would ask us why? Why? We just started to develop language for JVM. Why do we need for JavaScript? And to understand it, we need to check the landscape of the web development back then. So ECMAScript version started with like ECMAScript 3 in 1999. After that was a huge update in 2009 with a lot of different features. And in 2011, there was just a specification correction. And the language itself, like, there were a lot of nice updates, but the language itself was treated more like scripting language, obviously, just for small dynamism on your web page. So you're writing your UI mainly on HTML plus CSS, and some dynamism and changes was like driven by JavaScript. However, like front-end development was not like this. So there were a lot of enterprise-level frameworks in JavaScript that use JavaScript as the main language for defining both UI and logic. So there was Backbone, AngularJS, Knockout, Marionette, Meteor, Ember also released in 2012. And just to check how the application in JavaScript was look like, we can see regular Marionette application. So you see here this useStrict, just forbid using of older features. You see here user-defined module system, because there is no module system in the language yet. We see here kind of OP, because you're extending some class with overwriting things. So you see that a lot of things that expected from the language were implemented by users in the userland. So why there were a lot of players which actually giving this enterprise language into translation to JavaScript? So there was quite old solutions. I mean, JWT was in 2006, as far as I remember. There was Hex, which also somewhere around 2006. CoffeeScript was quite popular, announced in 2009, and was integrated with mostly of the framework I mentioned. Also, a lot of new players appeared. Dart in 2011, Elm, ClojureScript, and TypeScript, the magic of numbers, because 30 September, I mentioned that the first commit of Kotlin.js landed, and on the October 1st, TypeScript was announced. So why not Kotlin? Because, I mean, we already have those players, why Kotlin cannot play the same game? So with this idea, Kotlin also released JavaScript support. In 1.0, it was experimental. In 1.1, it was already stable and multi-platform. And the main use case was actually, as I mentioned it, we just use Kotlin with existing JavaScript ecosystem to write UI instead of JavaScript with Kotlin. Multi-platform was not there yet. So the first multi-platform application appeared on a JetBrains hackathon in 2016, this one. So it's just cross-compiled one SRC folder with JS toolchain and with Java toolchain and with symbolic link replacing the framework implementation. So for Java, it was Swing-based. For JS, it was DOM-based. So yeah, just a quick demo how it would look like. Yep, and on the screen, there is a link to this, so you can also try it and check how it is organized. So the idea of expect actuals firstly was announced in 2017, and you see the prototype of expect actuals was more like header impl. So header is expect, impl was actual. And yeah, the rest is the story. You know that multi-platform got some success, quite nice, and we already have iOS support, we have Kotlin native, and we need to run a bit further by our timeline to around a year ago. So around a year ago, I became a team lead of Kotlin.js team. And I've got quite a nice tool, I would say, because we had a stable compiler with a great incremental compilation, with Calib-based libraries, because before, in early days of Kotlin.js, there was different format, not compatible with any others formats. So it's more like JS in jars. And right now, it's like Calib as in other like native or WASM targets. Also, there is a good support in Kotlin multi-platform plugin, and I would say right now it's the only way to declare your Kotlin.js application. We have a rich ecosystem of libraries. Unfortunately, ES5 only support with experimental ES 2015. TypeScript generating and exporting were experimental still, and still not great in sense of bundle size, and good support in IDE. And the most valuable thing, with a fantastically active community. And yeah, but the use case was the same. I mean, 2025, we have use case like let's write React with Kotlin. And my question was, is it the only application to the technology? Is it the only use case we should have? Because, I mean, when we talk about multi-platform, one of the power of multi-platform is you choosing which piece of logic you would like to share. Do you want to share all application or just some data layer or validation layer or even just small function? So it's on your shoulders to decide what you want to share. And I just think let's empower Kotlin multi-platform because, I mean, there are different strategies for code sharing, and in all of them, Kotlin.js has some gaps. So, and also, I mean, this is what I actually declared in the blog post a year ago. But also what we wanted is not dropping other scenarios and previous scenarios, because we definitely don't want to break people who already rely on JavaScript. And with those two ideas, so let's not break early users and let's empower Kotlin multi-platform, we started to polishing the technology. So let's just dive into present. What do we have today? And when we talk about business logic sharing, there are definitely some improvements. By the way, when I say business logic sharing, I refer to use cases like you sharing in between clients, like here. So we sharing between Jetpack Compose and Vue.js application some logic, or you sharing between your backend and frontend, like here in the scheme when we're sharing between Angular application and Spring application. So what is essential for this use case? You would say definitely predictability and portability. So you want the same Kotlin code running across all the platforms in the same way. Definitely you want to export your code to consume it in TypeScript. For sure, you want to deliver by somehow your library to your front-end application. And definitely you want a small bundle and no performance penalty for choosing technology. And at this point, I would say one item is completely finished, and the other, we are on the finish line to finishing them. We will see it in the future section. So when we say about delivering to the native application, you have two options here. So the first one is keeping everything in monorepo. The other one is actually to publishing your KMP library to NPM or to your private organizational vault. So with the monorepo, it's not a rocket science. We have it everywhere in our Kotlin JS examples, like the one I mentioned with Vue.js or the one I mentioned with Spring, the default one which is created by multi-platform wizard. So in sake of simplicity, inside those examples, we are using monorepo, just with the package in JSON workspaces. And yeah, by the way, you can just navigate here and check all the examples. So, and yeah, the same as I mentioned, when you're creating the project with Wizard and do not share UI on the web, we're also using monorepo. When we're talking about publishing NPM, before last year, we didn't have any solution for this, official one. There was some community solution, and we adopted this solution. So since last year, NPM Publish is already official, so we're officially supporting it under the Kotlin organization, and you can just add it as a Maven publish or just like in libversion STOML, and you can deliver your NPM, your library into NPM or private vault. We also have a tutorial recently written on how to do so both on CI or locally, so you can check and play around with it. So when we talk about export, before we started polishing, we had those declarations to be exportable. We extended this list, and we are not going to stop with only those declarations. We will see it in the future. So right now, what is available for you, you can actually, on the Kotlin side, to declare an interface with the suspend functions and implement it as a TypeScript interface, implementing the promises-based functions, and pass it back like as a Kotlin implementation. And it works, even right now with 2.4. And yeah, we will see in the future sections that we like mostly on the finish line on extending the list of declarations. When we're talking about like writing both UI and business logic on Kotlin, there are also what is essential. So you definitely want rich ecosystem. So you don't want to re-implement yourself calendar or I don't know, search after complete. And also you want like fast and responsive UI. So definitely you don't want user pays for your choice of the technology. And right now you have also 3 options here. Depends on what your needs. So you can share UI across all the platforms and have pixel perfect UI across Android, iOS, and web. You can build in Kotlin without relying on HTML, JS, and CSS with Compose, but instead of rendering on canvas, rendering on HTML. And you can rely on the well-known and major solutions like React, as I mentioned, like our old focus when you're just writing Kotlin with React or with other JS frameworks. So this is what actually we also described in this paper and in this table. So what we suggest for which use cases, and we will just right now dive into this document a bit. So when we talk about sharing UI across different platforms, you know all the solution and the answers. What is the answer? Yeah, Compose multi-platform. So you have a pixel-perfect multi-platform framework which just rendering across all the platforms. And here, for sure, we suggest to you to use Kotlin WASM because it is fast, and it right now like all the modern browsers support it. However, you may ask me, what if I want older browsers? And we also have a question right now, because before last year, we would say, you will have a blank screen. But today, we have a thing called Compose fallback mode, which is actually the following thing. In the web main source set, you're writing everything web specific. And this web main source set is a common source set between JS source set and WASM.js source set. And there is a special task in Compose called Compose compatibility distribution, which generates a special distribution which on runtime check if the browser supporting everything needed for running WASM. If so, we're running fast version of WASM. If it is not, we're running JS. So instead of blank screen, you still have work application, maybe a bit or less slower. So, and yeah, this web main works like this. So if you already work with wasm.js and compose, you need just rename wasm.js main with a web main and run this task. And magically, you will have this compatibility mode. If it doesn't work, please connect to our Kotlin Slack channel and just share with us your issues and problems with this source set. And I mean, this source set is not something compose specific. It's actually quite usable for library authors as well, because it's integrated in Kotlin Gradle plugin. So if you're library author and you tend to support both JS and wasm.js, you can write your web-specific logic only in this source set and in Gradle to add JS and wasm.js support, so you can have 2 by 3. So the next question is, as you know, compose multi-platform drawing everything on canvas. So what if you don't want to have canvas? And here we are moving to this compose HTML-based solution. So compose HTML is an experimental thing which we worked on in JetBrains, which is use compose runtime and compose rendering system, but instead of drawing on canvas, we just rendering HTML native elements. And have I mentioned that our community is awesome? Because of it, a lot of community solutions appeared based on Compose HTML. And right now we have like Killua, which is a framework based on Compose HTML. Cobweb, which is also Compose HTML-based solution, and I believe author of Cobweb maybe even sitting something here. So you can ask him about Cobweb. And by the way, he also had an awesome talk last year on KotlinConf. And also quite a new one called Samon, which also support server-side rendering, lazy loading, and hydration. So you're getting this more modern web stack by using Compose. So, and yeah, so typical application looks like this. I mean, this is a component. I know it's not so visible. However, you see the structure is just similar to Compose. So you're writing just Compose, but instead of rendering on canvas, you're rendering on HTML. And you're getting actually the best from the 2 worlds. So you're still using Compose and Kotlin. You still can have your favorite stack, like persistent storage or DI, so what you're already familiar with. And as I said, some solutions already propose some server-side rendering, lazy loading to make your applications much faster for the first rendering. And also you have this native browser experience. So search on the page work, password manager autocomplete works, I don't know, auto translation by Google Translate also works, SEO, accessibility, everything just out of the box, because it's the like features of the browser which works with HTML solution. And even if it's a community solution, you still have possibility to use major solution from other technologies, because Compose HTML also supports this interop with React components. So if there is no component like for Cobweb, you can just adopt any React component as a composable for Cobweb or for Samon or for other Compose HTML solution. And yeah, of course, if you need something not created by community, but something well-known, major, and which has a decade of expertise inside community and a lot of engineers, so as I said, we're still supporting running Kotlin with React. So there is definitely still room for improvement. And as I mentioned, we're working on making bundles smaller, performance faster, to extend the list of exported things, and for sure to like improve the predictability and portability. Regarding the future, so team focused on a lot of things, to be honest, and you see this is the list of them. However, since we have not a lot of time, I would focus on those 3. So regarding export, we have like, so just a side note, in my team, everybody likes anime. So every internal project we just named in some anime character or some anime title. So let me introduce you to the greatest an internal project called Project All Might, which is actually what we want is everything stable in sense of export, and every Kotlin declarations would be exported, and ideally consumable in a TypeScript native way. So also as a part of this project, what we want, so I mentioned that those list is extended, and this is what we right now either work in progress or will be landed soon. So all the type of declarations are covered. And one more thing, part of this project, we don't want any more JsExport to be required. So annotation of JsExport will be not the only one way to declare that something is exported. So what we want, we already have a nice DSL for Swift export. Let's make something like JsExport. Or even more, let's just go and have export DSL with some specialization for different platforms. So this is what we want. Regarding better bundle size and performance, there is another great project, and let me introduce you Project Luffy, which is actually like the work we're doing on the bundle size, and consists of two parts. So the first one, we want to apply more advanced optimizations based on data flow analysis and effect analysis. But also the main point of it is actually generate JS mostly identical you would write manually. So the JS tooling will know how to optimize it in the final application. And for sure, we need a better JS tooling in this case, right? So, and when we say cleaner JS code, I mean that ES modulus with the quite new defer import feature, per file granularity, ES 2020 as a default target, and modern tooling integration to be able to trim the code you don't use. And the question would be, what if you need an older browser? And I mean, the answer is quite simple. From your side, nothing changed because we already integrated the thing called SWC. So it's a transpiler from the modern JavaScript to the older JavaScript. So at the end of the day, compiler generating modern JavaScript, and this tool lowering it to the JavaScript you need. So you, as a user, don't lose anything. And because we are already talking about tooling, there are a lot of things we would like to improve, and actually we started to improving and some work in progress. So the first thing, actually my favorite meme from our Kotlin Lang Slack channel. And yep, as in my native language, people say, meme is funny, but situation is scary. So we definitely would like to improve the DX with log files. And one of the first steps we would like to do is no need to update log files on each Kotlin update. So log files will be updated only when you update your NPM dependency or like library which depends on some NPM dependency. But if we talk about our dev dependency which are used by Kotlin, there will be no need for this. Second thing, second elephant in the room is Karma, which is quite maybe 2 or 3 years deprecated, and we're dropping it. So no more Karma in Kotlin build tools, in Kotlin Gradle plugin, sorry. We will adopt Playwright for running your browser tests. The same with Webpack. We're dropping Webpack, and we want to use Vite instead. But you see, we don't want just to stick with Vite for decades like we had with Webpack. And our idea behind it is we will provide a reasonable default for you and some API to replace some bundler. So if you don't want Vite and you want, I don't know, ESBuild or Bun or something like that, yep, there will be API, so you can replace it and choose your favorite bundler, which is more suitable for your use case. So yep, this is about the future. And I would say this future not so far, because our deadline for it is the next Kotlin Conf. So the next Kotlin Conf, all of the mentioned things will be available. Isn't this exciting? Thank you, thank you. And let's talk about more further future, because all of this work, my team working and the other teams in Kotlin working, open a lot of different doors and a lot of different integration for us. So what the next steps could be, imagine that we can provide some native libraries for React or for Vue.js, so you can adopt your compose view models just by using hook in React, and everything will be re-rendered, or as a composition API in Vue.js. Also, the thing I took from the example with Angular, with sharing between Angular and Spring, imagine that we can not only generate from your controller an API to be consumable in Angular, but also it will be integrated with the dependency injection system in Angular. So you will just integrate and like just import things like this. So this is what actually exporting giving to us. If we talk about cleaner generated JavaScript, for sure there is some experiment we are trying to integrate into Kotlin called service loader. So with per file, it will be possible to actually dynamically import things from Kotlin.js, like class, just import it lazily. And it opens doors for actually lazy and dynamic import in Kotlin.js, which is available in JS. But because we experimenting with it multi-platformly, so this API will be multi-platform for all the platforms, including WASM. Also, more atomic loadings, and I would say that with those improvements, I hope even more and more community solutions will adopt server-side rendering. And also because it's cleaner, just clean JavaScript, you can also use web components. It's just clean solution for another framework with Kotlin. And regarding tooling too, you heard about build tools API. Oh, sorry, before build tools API, you see how terrible right now is set up in JavaScript? So what we want is actually to remove all of these things because a lot of noise are here. So let me just create something like this. So you as a Kotlin developer, you maybe don't want even to know that there are different JavaScript versions. You just want to run something like, I want minimal version Chrome, I don't know, 95, or I want Safari 16, or something like that. Or even further, because we integrated with SWC, we're able to adopt browser list. So we can use browser list query, and you can say declaratively, hey, I just want browsers that have more than 5% adoptions in European Union, and that's it. So you don't need even know what exactly minimal versions of browser. Also, regarding build tools API, you hear on the keynote, and you will definitely hear during those days. It's also open door to Gradle be not the only build system, and to integrate also with Ampere, with Maven, with Bazel, with Bach, with any other tooling that providing you building and dependency installation. So our mission actually is to improve your experience with Kotlin.js and to make it enjoyable. And because we talking with you, especially in Kotlin Lang Slack channel, I see how many different really awesome solutions you're providing to us. You're really inspiring us, and your needs actually driving and guiding us what should we improve. So thank you so much. I really recommend to join Kotlin Lang Slack channel because I'm usually answering different questions there. So if you just have any feedback or want to share your pain point with Kotlin.js, you are welcome. And thank you. Yep. So do we have some time for question answers? Yep, yep. Great. No questions. It was so clear.
Is it working?
Yep, yep, yep.
Yeah, thanks for the presentation. What I was very happy about is that you were focusing on compose HTML. That's something I was missing already for a few years because we went on the compose HTML implementation from JetBrains themselves a few years ago, and we felt it was a bit forgotten. Mm-hmm. But is it still? But you focused on Cobweb and the other ones. Is compose HTML? Will that be more worked on still, or it's pretty stable and it works already in production quite a while? So what's the vision there?
So I would say like this, right now we are more focusing in JetBrains on compose multi-platform, so on rendering on canvas. However, we interacting with community, so we have some close interaction with Cobweb author, with Kilo author, and for sure we are working to compose HTML be stable for them. So as soon as they providing to us, hey, we figure out some issue in compose HTML, we're fixing it. But it's more, I would say, maintenance for them rather than we are productize it.
Yeah, okay, so that's good to know. Yeah, for us, the compose HTML bare bones library is pretty perfect because it's also a very good gateway for React developers to go to Kotlin, and the translation is very easy, so it's a very good library in itself, I would say. So thank you.
Cool. Thank you for feedback. Any more question? Hi.
I'm curious about, I saw the browser support stuff, which is very cool, but what about backend runtime support, so like Bun or Dino and that kind of thing?
So it's hard. So it's definitely not in priority list. However, what could be like beneficial for us that right now we are like exploring and researching how can we do the same for WASM, because for WASM, especially outside of browsers, there are also a lot of runtimes. So we actually discussing a lot and experimenting on different how could it be from the DSL perspective to integrating their runtimes. And for sure, if we figuring out how to do it for WASM, we can adopt the same solution for JS. So it would be easily the same to change in between runtimes. But I would say it's more like right now it's on the stage of discussion rather than even on prototyping. Any more questions? Cool. Okay. Thank you so much. Oh, yeah. I see one more question. Sorry.
Hey, I saw you focused a lot on React. I was wondering what about React Native? For example, Shopify is using React Native. And of course, React Native, it's a small technology and it has its limitations. And when Shopify meets these limitations, they build with Kotlin multi-platform. I was wondering, what do you think about that? Is there anything you can say about it?
So, yep. Let me clarify one thing, that from the compiler perspective, not from the build tools perspective, but from the compiler perspective, we don't even know to which runtime you generate. We're just generating JavaScript. So if we're generating JavaScript following spec, we expect that it's running everywhere like predictably, right? So when you declare in the tooling, for example, in Gradle that, okay, I want browser or I want Node.js, it's not only like notifying to Kotlin Gradle plugin to generate extra tasks to run in Node.js or to run in browser or to add karma, etc., etc. So if we talk about like compiler specific for Kotlin, for React Native, sorry, I believe there is not a lot of things we can do on our side for the compiler. From the build tools perspective, I feel, I mean, when you're generating it as for browser or even as for Node.js, it should work on React Native. So the only thing is when we're using maybe in standard library some API that is not available on React Native side in Hermes virtual machine. However, with SWC integration, what I mentioned, it should be fixed. So we're generating thing following the spec, and it will lower it and add polyfills, which is needed for React Native as well.
Thank you very much.
Yeah, you're welcome. So, yeah. One more question, no? Yeah, I see one.
Yes, so thanks a lot for all your hard work, especially the web target, which covers both WASM and JS, is an amazing one. And for me, it gives a feeling like Compose on the web is production ready. Is it just feeling, or do you advise it
I would say, as far as I remember, it's right now in beta.
Yes.
So, and we are on the road to be stable.
Yes, but like for me, it looks like the main pain point like we had in our company like a year ago, that we couldn't support the old browsers. Like, would you advise still like to wait or already start like prototyping and maybe looking to use in production?
I mean, regarding starting prototyping, you can even do it when it's experimental, right? But yeah, beta is already like a good enough stability to start prototyping. Regarding production, actually, like my opinion, I would wait a bit regarding production.
Okay, thanks a lot.
Okay, yep. Thank you so much for participating, and thank you a lot for your questions.